Hi, so in this video I am going to show how to solve the problems on sequencing model in operation research. So under the category of n jobs are assigned on m machines. So the previous video, so I have explained how to solve the problem on n jobs on 2 machines and n jobs on 3 machines. So this problem deals with n jobs on m machines. Now I am going to read out the problem. There are 4 jobs A, B, C and D which is to be processed on machines M1, M2, M3, M4 in the same order. In some other problem, the order may be shuffled. For example, it may be M1, M3, M4, M2. So whichever is given in the question, we have to proceed with the same order. But in this problem, the processing will be in the same order of M1, M2, M3 and M4. Okay, the processing time in hours is given in the table, so we have to find out the optimal sequence and total processing time or total elapsed time. Okay, right. So we will move into the solution part. So here there are 4 machines and there are 4 jobs. First we have to check the inequality. So there are two conditions. First one is find out the minimum value of machine 1. So minimum value of machine 1. So the first condition is the minimum value of machine 1 should be greater than or equal to the maximum value of machine 2 and machine 3. Okay, so in this problem the minimum value of machine 1 will be 12. So it should be greater than or equal to the maximum value of machine 2 and 3. So it should be greater than or equal to the maximum value of machine 2 will be 5 and the maximum value of machine 3 will be 10. Okay, so 10. So look at this inequality. So the 12 is greater than or equal to either 5 or 10. So this condition is satisfied. Okay, so this condition is satisfied. And so we will move to the next condition. So now we have seen the inequality for the first machine. Similarly we have to see the inequality constraint or condition for the last machine, I mean mth machine. So in this problem the mth machine is m4, I mean fourth machine. So I'm going to so the m4 should be minimum of m4. The minimum time in a machine 4 should be greater than or equal to the maximum time in machine 2 or machine 3. So in this case the minimum value of machine 4 will be 12. So it will be 12 should be greater than or equal to 5 comma 10. So in this case the second case is also satisfied. So this condition is also satisfied. Okay, so both the conditions are satisfied. So we can proceed the problem further. So in some cases any one of the condition may be satisfied. So if so at least any one of the condition must be satisfied to proceed the problem further. Okay, so now so we have to convert this 4 m machine problem into 2 machine problem. So here there are 4 machines, so we are going to convert this problem into 2 machine problem. So let's see how it is. Now I am going to assume two hypothetical machine which was assumed in the last problem. That means n jobs on 3 machine problem. I have posted in the previous video. So now I assume there are 2 machines, that means hypothetical machines G and H. So G means so we have to sum up the processing time of machine 1, machine 2 and machine 3. In H we have to add the processing times of M2, M3 and M4. Okay, so for job A, the G value will be we have to add M1, M2 and M3. So 15 plus 5 plus 4, so equal to 24. So this is how we have to calculate the hypothetical machining process time G and H for each job. Okay, so for job we add 12, 2 and 10, so this becomes 24. And for job C add 13, 3 and 6, so this becomes 22. And for job D add 0, 16 and 3 becomes 19. So similarly for job H, so we have to add 5, 4, 14. It means M2, M3 and M4. So 5 plus 4 plus 14, so equal to 23. So in this way for B machine 2, 10, 12, so same 24. For for job C, the processing time for H will be 3, 6 and 15, 9, and this becomes 24. And here, so it will be 22. So this is the processing time for two imaginary machines G and H. Okay, so this is how we have to find out it. So now find out the optimal sequence. So based on these values we have to find out the optimal sequence. Here there are four number of jobs, 4 jobs. So I'm going to make a box of 4. Okay, so as we did in the previous problems. Okay, so from left to right, so G machine, from right to left, so it will be of, so from left to right, so we have to fill up with the processing times of machine G, and from right to left it will be for H. Okay, so first fill with the start with the H. So we have 24, 24, 22, 19. So among these values, the minimum value will be 19. So 19 falls under G machine of D job. So first we have to process the job D. Okay, and so now I'm going to strike out this timings or column. So now we will shift into H machine. So here the minimum processing time will be 23. Okay, so in 23, so machine for A and machine H and job A. Okay, so fill the GA at last. Okay, and so strike out this column, and again move into G machine. The minimum processing time will be 22 for C machine, so put C here, and finally we have B. Okay, so this is how we have to find out the optimal sequence. So and then we have to find out the total elapsed time. So now to find out the total elapsed time, so make a table like this. Okay, so first one is optimal sequence. Then we have to fill up with the machining processing times of individual machines, and in addition with that, so I'm going to find out the job ideal time and the machine ideal time. So as for the optimal sequence, the first job will be D. So first job will be D. Okay, so we are going to start the machine 1 at 0th time. So the in time of job D will be 0. Okay, so always the in time of the first operation will be 0. So next, the processing time of D in machine 1 will be, see here, the processing time of job D in machine 1 will be 16 hours. So fill 16 here. Okay, and so once the process is completed in machine 1, it will be loaded or moved into machine 2. So until that, the machine 2 should be in ideal condition. So here there is no ideal condition for machine 1, but machine 2 should be in ideal condition for 60 minutes to receive the um, D job from machine 1. So the machine ideal time will be 60 minutes. Then the job in time, loading time into the machine 2 will be 16th minute, and processing time in machine 2 will be 0. So the the job out time will be 16. Okay, and the job in time into the machine 3 will be the same 16. So again we can say the machine 3 also should be in ideal condition for 16 minutes to receive the job. Okay, so the processing time in machine 3 for job D will be 3 minutes. So the out time will be 19. Okay, so 16 plus the processing time 3, 16 plus 3, 19, and so this out time will be the in time of next machine 19. So the machine 4 should be in ideal condition for 19 minutes. Okay, so the processing time on machine 4 for job D will be 19 minutes. So again 19 plus 19, 38. Okay, so in this case the job is not ideal in between these machines, so the job ideal time will be 0. Okay, so this is how we have to fill the uh, table. So next job will be C as per the optimal sequence. So let's see here and listen. The machine 1 takes 16 minutes to complete its first process on job D, about 16 minutes. After 16th minute only, so we can able to load the job C into machine 1. So the next job can be started on machine 1 at 16th minute only. Okay, so the processing time of C on machine 1 will be 13 minutes. So 13 plus 16 will be 29. Okay, so the out time of this machine 1 will be in time of next machine, that means machine 2. So 29, the processing time 29. Okay, the processing time will be of C in machine 2 will be 3 minutes. So 29 plus 3 will be 32. Okay, so here we have to find out the machine ideal time. So the machine 2 is ready at 16th minute for the next job, but the second case the job can be loaded into the machine at 29th minute only. So the machine M2 should be in ideal condition about 13 minutes. Okay, machine should be in ideal condition about 13 minutes. So there is no ideal condition for machine 16. So next, so in the first case for D job, the machine M3 is available at 19th minute onwards, but the in time of the next job will be 32th minute. So the machine M3 should be in ideal about again 13 minutes. again 13 minutes. Okay, so the processing time in M3 will be 6 minutes, so this becomes 38. Okay, so here the out time of the fourth machine, the D job will be 38. Here the job is ready at 38th minute, so there is no job ideal time and there is no machine ideal time. So in time will be 38 and the processing time will be 15. So 38 plus 15 will be 53. Okay, there is no machine or job ideal time in job C. Okay, so as per the sequence, the next job will be B. So the out time, put the out time here, and the processing time of B in machine 1 will be 12 hours. So 12 plus 19 will be 41. So look at these values, 41 here and 32 will be here. So the machine 2 is available at 32nd minute, but so it may receive the job at 41st minute only. So until that the machine will be in ideal condition. So the machine ideal condition will be 41 minus 32, this becomes 9. Okay, so the processing time of B in machine 2 will be just 2 minutes. So 41 plus 2 will be 43. So look at here, the machine 3 is available from 38th minute onwards, but it may receive the job at 43rd minute, so it has to wait for 5 minutes. So the machine 3 will be in ideal condition of 5 minutes. So at 43rd minute it receives the material. So for B job, the machine 3 takes 10 minutes to process the operation. So 10 plus 43, 53. Okay, so in the previous case the machine is available at 53rd minute. So here the job is loaded at 53rd minute, so there is no ideal condition of machine 4. Okay, so the processing time will be 12. So 12 plus 53, this is 65. Okay, and finally we have job A. Okay, the job A in time into the machine 1 will be 41th minute, 41th hour. Sorry, all the times are in hour. Okay, sometimes I may read out it as minute. The processing time for A in machine 1 will be 15. So 15 plus 41 will be um, 56. Okay, so here the machine is available from the 43rd minute onwards, but the job is loaded into machine 2 is 56th minute. So the machine 2 is in ideal condition up to uh, 46 minus, sorry, 56 minus 43, this is 16. Okay, and the processing time of A in machine 2 will be just 5 hours. So 5 plus 16 will be 61. So after 61th hour it will be loaded into machine 3, 61th hour, but the machine 3 is available from 53rd minute onwards. So the machine 3 should be in ideal condition up to 61st minute. So the machine 3's ideal time will be her 61 minus this 53, and the processing time will be 4 hour. So 4 plus 61 will be 65. Okay, so here the machine 4 is available from 65th minute. So here the job is loaded at 65th minute, so there is no ideal time in fourth machine. So processing time will be of 14th hour, and 14 plus 65 will be 79 hour. So there is no job ideal, so as per the sequence, the the total elapsing, okay, total time elapsed will be total elapsing time will be equal to 79 hours. Okay, and total machine ideal time, total job ideal time, total job ideal time. So there is no job ideal time, so job ideal time will be 0. So the job is not waiting for the machine. Okay, then so the machine ideal time will be, so look at this here. The cycle takes 79 minutes to complete the entire process. To complete all the process on all the 4 machine on all the 4 jobs, it takes 79 hours. Okay, so okay, right, so this is the one cycle time. But for machine 1, the machine 1 completed its last job at 56th hour. Okay, so once the cycle is completed, the next cycle will be started. So until that, the machine 1 should be in ideal condition. So the cycle takes 79 minutes to complete, but the machine 1 completed its entire processing at 56th minute. So until that, the machine 1 should be in ideal condition. So 79 minus 56 equal to 23 hours. 23 hours. So the machine 1 ideal time will be 23 hours. Similarly, the machine 2 ideal time. So first add all those values. 16 plus 13. So 16 plus 13 plus 9 plus again 16 plus, so look at this here, the cycle time, the total elapsing time will be 79th hour. Sorry, again I am telling minutes, so all the parameters are in hour. Okay, so the cycle time is 79 hour, but the machine 2 completed its all processing will at 61th hour. Okay, so we have to calculate uh, 79 minus 56. So this is the ideal time for machine 2. So this will be 16 plus 13, 29, 29. So the machine ideal time, second machine ideal time will be 77 hours. Similarly, machine for machine 3, the ideal time will be add 16 plus 13 plus 5 plus 8. So 29, 29 plus 13, 42. So 42 plus here the cycle time 79 minus 61, sorry 65, 79 minus 65. So 79 minus 65, so will be 56 hours. For machine 3, sorry 4, the ideal time will be, so machine 4 ideal time will be 19 hours. Okay, so the total machine ideal time will be, so the total machine ideal time will be 175 hours. Okay, so this is the solution for the given problem. Okay, thank you.